Okay, lesson 2, we're going to look a little bit more at the characteristics of polynomial functions. You remember the last lesson we talked about constant functions, linear functions, quadratic, and cubic. And what I've got here is a whole bunch of these graphs. Okay, now I've already put the answers down, but what I would like you to do is get your graphing calculators, and this is just good practice. If we can do this kind of stuff, you'll be in really good shape for your evaluation. What I would like you to do is graph each one, and once you've graphed it, I would like you to list the X-intercept, the Y-intercept, if it has a max or a min. Okay, and sometimes it'll have both. I would like the domain, like the range, and some of them will have a vertex, some of them will have like a maximum point and a minimum point. So I'll list them all here. Sometimes it doesn't exist. Like if you look at this graph, there is no vertex here. Okay, so basically we're doing the same thing that we were doing in the last unit here, where we had domain, range, X-intercept, Y-intercept, the relative max, min, end behavior, and number of turning points. Okay, honestly, the end behavior and turning points, not as important to me. You can do those as well, but really focus on using the calculator and figuring out the X and Y intercepts. Okay, so I'm gonna stop the video here. You guys can do A to I, and I will post the answers later. Okay, so stop for a while and finish those. Okay, so here are some of the answers posted. It might be easier for you if to Desmos.com and graph some of these there, because it's much easier to see answers. It's much easier to check your work. So I would say you can always use this. It's actually an app as well, if you want to download the app. It's great for checking your homework. So if you go through some of these, you'll be able to see how you did. Okay, let's go to the end here where there's a few things I want us to note. Okay, how would you describe the shapes of the different polynomial graphs? I've put the answers in here. Make sure that you're aware of this kind of stuff. I would read it, be comfortable with what it says. Some of these questions could show up. Okay. How is the constant term in a polynomial function related to the y-intercept? If you think about the graphs we've done, and we've had a whole bunch of stuff here, and then it's been plus, say, let's say 3. So we have 3x squared minus 2x, I don't know, making this up. If we make x equals 0 in these spots, then that turns out to be the constant. So the y-intercept is the constant when x is 0. Okay? How does the sign of the lead coefficient affect the end behavior? Okay, remember, end behavior is what's going on as we get x is approaching infinity. Okay, if you look at any of the graphs, so basically this means if the lead coefficient is negative, then the graph is going to end up there. Okay, if the lead coefficient is positive, the graph is going to end up this way. Okay, and remember what the lead coefficient is, that's the highest power of x. Okay. When the degree of n of a polynomial is odd, the graph has opposite behavior. So odd meaning like if there's a power of 1 or a power of 3, it'll be opposite. So either like this, or if they're negative, like this, and like that. Okay. If the degree is even, then we're going to get either this parabola going up if it's positive and down if it's negative. Okay, so these are some generalizations. I would go over them, make sure you understand them, but generally speaking, if you have the equation and you graph it, you're going to figure that out as you go anyways, so you probably don't need to know that. Okay, How is the degree of the polynomial function related to the X-intercept? Okay, basically, if you have the power, whatever the power of the lead coefficient is, this will tell you how many X-intercepts there are. Okay, but it doesn't mean for sure. It means at most 1. And if it's power of 2, it's going to be at most 2. It's possible that a parabola has only, so that would be 2. It's possible that it only has one X-intercept. Okay. So if it just would touch, and it's also possible that it doesn't have any X-intercepts. Okay, so that's why we say at most 2. Same with a cubic, it has at most 3. So it's possible that it has something like that, but it's also possible, and we've seen this, where we only have 2, and we've also seen where there's only 1. Okay, so that's what that means. How is the degree of the polynomial function related to the number of turning points? Okay, here the number of turning points will always be 1 less than the degree. Okay, so if the degree is 1, there's going to be no turning points. If the degree is 2, 1 less than 2 will be 1 turning point. And if the degree is 3, there will be 1 less than 3, which is 2 turning points. Okay, how can you predict whether a quadratic or a cubic function has a max or a min? Alright, again, this has to do with the negative or positive lead coefficient. It also has to do with, are there actually enough of a bump to have the max or a min? Okay, quadratic functions have a max or a min. For sure they will. Okay, but a cubic, it might not have them depending on what that relative max or min is. So, I mean, we've seen graphs that look like this. Right, that's not going to have a max or a min. It takes that bump to make the max, and it takes a bump to have the min. Okay, so looking at this, we're going to go for some characteristics, and it says determine the following characteristics of each function using its equation. Now, if this was a test and you were stuck, you could always graph it and you would be able to find some of that out. We're going to try to do it just by looking at the equation though. Okay, so for A, if I look at A here, let's fill out some information. So it's saying, how many X-intercepts could it have? Alright, well it could at max have 1 because it has a degree of 1. The Y-intercept, I can see it. If I make X is 0, that Y-intercept will be -5. What kind of end behavior is this going to have? Well, this is a positive X, so I know that when I graph it, it's going to look like this. So the end behavior is going to be as X approaches infinity, the graph will rise to the right. Okay, the domain for a line, degree 1 is always -infinity to infinity, and same with the range. And the number of possible turning points, a line has none. Okay, let's do B. B is f of x equals -2x squared minus 4x plus 8. Okay, first of all, how many X-intercepts does this have? At most 2, right? X squared tells me we could have at most 2. There might be 1, there might be none, but it has at most 2. The Y-intercept, if we put a 0 in where each X is here, we're going to get a Y-intercept of 8. Okay, next question is, what is the end behavior? Well, this has a negative coefficient, so you know this is a parabola that opens down. So as X approaches infinity, the graph will fall to the right. Okay, and then we want to do the domain. The domain for all of these graphs is going to be negative infinity to infinity. The range, well, the range we would need to know the vertex. Okay, and we're not going to get that just by looking at the graph. Okay, so we're going to leave that one blank for a second. I'm just going to say need the vertex. Okay, and this will have a maximum. It says number of possible turning points, so it will have one turning point. All right, and then let's do C. So f of x equals 2x cubed plus 10x squared minus 2x minus 10. Okay, first of all, it will have at most 3 X-intercepts. It will have a Y-intercept of negative 10. That's the constant. Okay. What's the end behavior? Well, it has a positive x cubed. So as x approaches infinity, the graph will rise to the right. So you already know this graph's going to look something like that. Okay, the domain, negative infinity to infinity. Range, negative infinity to infinity. And this will have at most 1 max and 1 min. Okay, so that means what? Therefore, 2 turning points. Now it's possible it doesn't have 2 turning points. It might only have 1. It might not even turn. It depends what that graph looks like. Okay? So there's what we're looking at just by looking at the equation, what we know already. Okay. So here we're supposed to match. So we're going to use the information from the equation to see if we can put it into the graph. Okay? So where do you start with this? Well, here we have an x cubed. Which of these graphs is an x cubed? Well, these two are. Which one of these is the correct graph? Well, you have a negative x cubed, so that tells you that it's going to be the last one. Okay? Let's look at the next one. This one is a parabola. So I see 2 parabolas here. They both open up, so I have to decide which one is the correct one. Well, if I look at the Y-intercept, it's negative 2. Which one of these graphs has a Y-intercept of negative 2? Well, now you can see this one has to be the second one. All right, this graph is a cubic graph. It's a positive lead coefficient, so I know it's a graph that looks like this. And you can see that it's the 5th one. Okay, so we've now eliminated this one. We've eliminated this one. And we've eliminated this one. Okay, let's do the next one. Which one is this going to be? Well, I see there's a lead coefficient of -0.5, so this one's going to fall to the right. It has a power of 1, so it's a line. So it could be either of these two. That's not enough information yet. So let's take a look at the y-intercept. The y-intercept is -3. What's the y-intercept here? -3. What's the y-intercept? -3. So again, I haven't ruled out any of them yet. So what do I have to do? Well, maybe we should look at the slope. The slope for this graph is -1/2. Okay, if I look at the other line, I see here the slope is -2. Which of these has a steeper slope? Okay, should make sense that this is steeper. Okay, it falls -2/1, where this one falls 1/2. So if you look at, for example, here, if you had a slope of -2, you would go down 2 units, and then you would go over 1. So this graph would look something like that. Okay, if you have a slope of -1/2, you would go down 1 unit and over 2. And so you would be on this graph. So this one is here, 3, and this one has to be the first one. Okay, and so we just have one left. That's going to be here. Okay. Example 3. Sketch the graph of a possible polynomial function for each set of characteristics below. Okay, so let's do A. This one says it has a range, and this says y is greater than -2. So we would write that as -2 to infinity. Well, that right there tells you it's got to be a parabola. Okay, because if we have, it's going to go down to -2 and it won't have anything down here. Okay, so we have some sort of a parabola. Okay, so it's going to be, down to -2. It also says it has a y-intercept of 4. So I want to go through this point, and I don't want to go below this. So let's draw a parabola, something like that. Here's 4, and this is at -2. Okay, let's do the next one. This one says the range is any real number, so this is from -infinity to infinity. And it has turning points, one in quadrant 3 and another in quadrant 1. So in quadrant 3 is here. Let's say this is a turning point, and we have a turning point here. Okay, and it says the range is from -infinity to +infinity. So we want to end up going like this and like this. Maybe, and these are supposed to be turning points, so maybe we'll turn here like this. Okay, and I want to turn also in quadrant 1. Okay, so I started with this, and then I was thinking, okay, if I want to turn like this, then how do I turn up here? A little bit confusing. Okay, so I want to be able to turn here, and I want to be able to turn here. The problem with this is going to have an extra turning point in there. So maybe I should go the other way. Maybe I should turn like this, and then turn like that. Oops. Turn here, and turn here. Okay, so there's a possible graph. All right. So I have another summary here. You should go through this. This is kind of clarifying everything that we did. What I would like you to do for homework is the next 2 pages in the notes. Okay, so this is just the next 2 coming up right here. All right, that's homework for this lesson.